Okay, so today we'll be working with the blog database. And like Sean has pointed out, if you are simply trying to get this up and running from the shell script, you're going to run into some issues because the build command isn't in there. And if we go to the blog database itself, or the repository for this database, it's very vague. It says to just run setup. Ah, I see. Yeah, yeah. I wonder if that was intentional. I wonder if whoever wrote this was trying to be tricky. Because if you do go to the cars database for reference, the first thing it talks about is to build the image. But I can definitely see where this can get confusing. So if you're having trouble getting this set up, be sure to run your build first. And you could use the cars repo as a reference on how to do that. And if needed, we'll run through that live as well. I should actually ask, is there anyone that hasn't set it up yet? Maybe we could get you to demo it right now. Okay. Kim, does that thumbs up mean you're good to go or you want to demo it?
Nope, I'm good to go. I ran into the same issue Sean did.
Okay, cool. All right. Okay, well, if we don't need to demo that live, we'll give you all some time to get set up with that while we talk about schema design, because that is the theme of the week. And today we're going to be talking about some relationships between a blog user, a post, and a comment. And then we're going to play around with that inside of a PostgreSQL environment. You should already have experience with, what is this, quick database diagrams. So you should already be able to sign in and play around with it. This is what we're going to be using today. I think one of the repos has a list of other database diagram tools. So if you have a preference, you could try some of those out too. Some of them are language specific, so they may not support Postgres, but yeah, quick database diagrams does, so we're using that. Okay. All right, we are going to keep things simple and we're going to stick with these three entities: blog user, post, and comment. And so let's get some boilerplate code up there. We want a blog, and everything's going to have to require an ID, right? So can somebody tell me how to create an ID with a key and what kind of key I need?
Need the serial primary key.
Yes. All right, how do I do that?
You type an ID space serial, as in serial number, and then you just space primary space key.
Okay, that didn't seem to work. I wonder if, were you all using any other kind of DB
I,
diagram?
I used this yesterday. I don't have my file that I had from yesterday.
I think on this one it's just a PK instead of a primary key.
That's right. She's right.
Cool. Now, one more thing.
I think after blog you have to have another line with like a dash. Or yeah, there you go.
Cool. All right, so there's our basic blog. And actually, we're not doing a blog, we're doing a blog user, right? So let's do blog user. Let's just copy this. It's going to complain, but we don't care because we expect it to. And let's just change these out to post and comment. Okay, now what are some things that these tables need? Obviously, a username is going to require, sorry, a blog user is going to require a username. Kind of gave it away there. So let's say name. And I want it to be a string, so can somebody tell me how to make it a string?
Varchar.
Yep, varchar. Anything else?
You could add like a 100 or 255 depending on the length.
Okay. And is there any kind of syntax I want to follow to do that?
Put in parentheses.
Cool. Perfect. So let's do that. And we could also just set a default value or allow for null. So it's optional. It's not absolutely required, even though it probably should be required. Um, they'll definitely need an email. So let's do the same thing. It's going to be a varchar. I don't know if that's a good character limit for emails, but we're just mocking this, so it doesn't really matter. Next, for a post, let's look at some more requirements. We want to be able to have posts that are made by a single blog user, and a blog user should be able to make as many posts as they'd like. So what does that tell us? What does that tell us specifically about how we want to build out this table? What do we need
A
to
reference.
yes, exactly. Need a reference. All right, how do we create that reference?
So I'd be like a user ID
Mhm.
as an int,
Okay,
and then FK for a foreign key, and then I believe it's greater than and dash, and then this would be blog user dot ID.
cool. Let's see if it likes that. It likes that. All right, quick database diagram says happy. We have a relationship between our two tables. And let's press on. What else do we need for a post? I guess a title and some text, right? So let's give it a title. It's just going to be another string, so we're going to use varchar again. And we want it to have some kind of content. So let's do another varchar for text. All right, what is our next requirement? Now, a comment should be made by a single blog user. So just like the relationship between post and blog user, we could recreate that. So a comment should be able to be made by a single user, and a blog user can make as many comments as they'd like. Because the foreign key is coming from the blog user ID, we could have multiple entries for different comments from that user. Okay. Now we want a comment that can belong to a single post and a post that can have many comments. So far, really the same pattern. We're repeating the same pattern here. So let's do just that, but with a post ID. And then we'll point it to post instead of blog user. Cool. So how is this looking? I think it's looking okay so far. All right, so we have blog users. Their IDs are referenced whenever they make a post and whenever they make a comment. What else? And it's the same with a comment, right? A comment references a post. So we have our relationships set up. Now, this last one is apparently a little tricky. A comment can belong to a single comment. And again, a comment can have many comments. So how do we allow for comments to belong to other comments? Who wants to take a stab at this one?
You reference like a comment, like you make a new, I forget the term what you call, like what would you call post under underscore ID. You make a comment underscore ID. You make its foreign key to the comment dot ID.
Okay. Let's
What do
give,
you call those? I'm drawing a blank. So like ID user underscore ID. What are those? Are those variables? Are those
yeah, I guess you could call them variables.
okay.
It depends on the context. You could think of them as columns because we're,
Columns? Okay,
yeah.
yes, that makes sense. Thank you.
Mhm. And we wanted to point to, you said the comment ID, right?
Yeah, so basically it's pointing to itself, but the comment dot ID wouldn't be itself because it would be making a new ID that would point to an original comment. So it'd
Mhm.
be a comment within a comment.
Yeah, sounds good to me. And quick database diagrams is also not complaining. So that should be exactly what we want. And let's compare it to our image here. Yeah, I don't know why they have everything floating that way. So host going to, yeah, this looks just about the same. Cool. So that's schemas in a nutshell. I don't think your use cases will get a little too much more complicated than this. Maybe once it gets time to create your projects, both personal and group projects. The tricky thing about this, or what tends to be tricky about these, is as you're building out your schema, you might be thinking of other things that your tables need or that you'd like for your tables. Like, for example, we have name and email for blog user, but what if we wanted first name and last name? What if we wanted, I don't know, a way to track their address, their phone number, things of that nature, right? And we're going to start to expand and have a lot of different columns inside of that schema, and it might get complicated. Or if you're maybe working with, I don't know, like less straightforward relationships where a process might be like very complicated. Like let's say maybe a loan servicing application, right? You have a user that will have applications, but they'll also have bank accounts, an account for the application itself, and the way that leads are found. Basically, there's going to have to be like another table for opportunities. It can get really complex over time. And the best way to go about it is to stay as simple as possible and add features as you go. Ooh, but now I'm wondering, do that, but also as you're designing your schema, know ahead of time what the critical components of your application is, right? So definitely at least know what tables you're going to want. That way you can have a solid foundation that will be easier to build upon than if you were to try to start squeezing in, like let's say if we wanted some kind of a table in between posts and comments, that might require separating some of these relationships. I mean, I don't know why we'd want to do that, but that's it can get out of hand really fast the more complicated your use case. So don't skip the schema design part. When you jump into making your databases, this is a pretty useful step in preventing yourself more potential issues to troubleshoot later on. Okay, that is, I guess, my pitch for why you want to use schema design or best practices for this sort of stuff. And now let's look at how we would actually implement this within an actual database. So I think all of you should have your databases running, right? Cool. Now, if I were to do a Docker PS, we could see that I've got mine up and running. Let's go back to our repo, and we see these blocks of code that we don't have to run because if you paid attention to the contents of some of these files, if we go inside the Docker file, for example, actually, before we go there, let's go to our init.sql because here we'll see the same code as in the repository. So we already have a SQL file inside of this repository that creates these tables. And just like it shows inside of this example here and matching what we have in our schema, we want things like primary keys. We want things like references. Syntax is a little different, but here in our post table, we have a user ID that is referencing a blog user ID. So it should line up uh, pretty closely with your schema design, just minor changes in syntax, how things are written. And the reason we don't have to run this manually is because if we look inside of our Docker file, what do we see? We see that this is copied into a Docker entry point directory. And when we go back to our init script, or not, is it called init? Let me see, setup.sh. Well, first you want to build the image, right? Because that's the command that Sean was pointing out that wasn't inside of the repository. But once you've built it, you are running based off of the name of that image, which in this case is just pg_db. And we can set a remove flag so that when we stop this container, it will terminate and disappear. We then pass in some environment variables, like a password for our database and a database name. And let's actually look back at our repo. So blog schema says to reference carsdb, and our command here says to build it with this with a name like this. Again, this last argument, this is a symbol that represents your present working directory. So you're telling this build command to look for a Docker file in the same directory you're in. You then run a container from the image. And again, we're passing in the same environment variables. All right. Last thing that's probably important is when we go to execute a command, we want an interactive terminal. So we use exec. It's already running, so we use exec to run another command. And we're again referencing our image. And we are passing in we're passing in an entire command and like some arguments along with that, right? So we are running PSQL. We are also setting the local host and port and user as we do that. And this is a little tricky here because it looks like the exact same flag as above here, but is it just blog? Let me see. Because I think that's how it was, right? I don't think I changed that. Yeah. So let's see. Let's run this right now, or let me do a Docker PS. My image is called blogdb, and my container is just called pg_db. Let's try running this command on its own. And we see that we're inside of a blog database. Oh, yeah. Okay. I tripped myself up. Sorry. So what's happening up here is we are running in detached mode. This is the actual environment or argument that we're passing in for the p-SQL command, right? Here we were setting an environment variable to use, but we weren't running p-SQL. So this isn't the database name. This database name and this argument, while it's using the same character, it's for a different context, right? This is for a run command. And so in this case, we're passing blog_db to run, and the flag that we're using, the option that we're using is detached. And again, we could use very useful commands like -help. So if we do Docker, we could even do it on Docker run. We run a help on Docker run, and it will tell us that this -d option is to run a container in a detached state. So that allows us to exit out of the container without actually stopping it, because if it stopped, then it would terminate because of this rm argument. So now we can just run exec commands to run commands that we're passing in. And in this case, we were passing in, right, things like the host, the port, user, and the blog. And so the name, which is blog. So let's run that again. And let's see what's happening inside of here. If we do \D for describe, we will describe everything inside of this database. And we've got 3 tables set up: a blog user, a comment, and a post. And if we do describe on one of these in particular, we get to see the columns that it has, along with some additional information like foreign key constraints. And so let's do this for comments and post as well. If we were to try to do it with the same describe command, it's not going to work. It's going to ignore that second argument because this command only takes 1 argument. So we have to run for each individual table that we want to describe. So now we have our column names. If we wanted to look at our tables another way, we could do a very simple select statement, right? So select all from, let's say, what was that? Blog user. Yeah, all lowercase. Blog user. And then we could just set a limit of 1 if we were, for example, only interested in seeing what the column names are, right? And then you always close with semicolon. And this tells us we've got an ID, we've got a name, we've got an email, just like in our schema. Now let's do the same, but unlike the describe command, we could actually do this with all of our tables. So let's do this with blog user and comment. And it's okay. We don't really get clarity on what columns belong to what. You could infer based on where the ID appears. But when you're working with, let's say, maybe databases created by other people or other teams, or they're already existing in whatever job you land, right? You may not know ahead of time how these tables are set up, and it can be a lot to just use a bare bones select statement like this. So generally, you don't want to do like a cross join like this. We've learned instead that we want to use things like an inner join, right? So let's do a select. Let's do a select all again from, what is it, blog user. And when we were talking about our relationships, we have a blog user ID that is mapped to, or no, sorry. We have the blog user. It's weird saying that. blog user ID, not user underscore ID, but the blog user ID mapped to a host user underscore ID. So from blog user, if we want to join with host, then we can say post.user underscore ID equals blog user dot ID. Okay. All right. What am I doing wrong?
Then you got to put on join post on
Yes.
ON.
Good call. So we have to do the end because join is where we specify the next, what is it called? Table. And then the on is where we set what we're trying to match for. So let's try this. And wow, that's a lot of information. And we might not want all of that information. Ooh, I was supposed to do comment first, actually. I was going to demo comment first. If we do comment.user ID instead of post, which I need to update, let's join first. We get a lot of info. Again, it's a lot of info, so when we exit out of that view, it's not going to appear here, right? If we did a simple limit, like maybe by 5, it's as it loads, it doesn't require us to navigate with our arrow key, so it just stays with our terminal. So it's like a record that we get access easily. So when we're trying to see all of this information from multiple tables, let's add another join, for example, and now let's add that comment, sorry, that post table again. So join post on post.user ID, matching the blog user ID. And we, again, run into the same issue of there being way too much to look at. And I'm going to say it's probably because of this text column, right? The text column is where we have a boatload of information, more than we need or want, right? So instead of doing a generalized select all, we could be more specific about what we're looking for. So like, let's say if we wanted to look for IDs, let's go ahead, grab ID, name, email, text, user ID, host ID, parent ID, parent comment ID, apparently. And what else did the post table have? We want everything in the post table except for text. So we've already got ID and user ID. So let's just add title. Now, what is going to happen if I hit enter? I'm going to give a hint. It's not going to like it. If you're following along, try it in your own terminal. No takers, no guesses.
Mine says that the ID is ambiguous.
Yes. And why is that? That was Danielle, right?
Sorry, I didn't hear what you said. My
Why
kid
is
started screaming.
Oh, sorry. Yeah. Yeah. So why is that? Why is it ambiguous?
Because there's multiple tables with IDs in it.
Exactly. Exactly. So what can we do to be less ambiguous?
We put the table name dot ID.
Exactly. So it's going to complain. So now let's be more specific. We can do the table name.id. So things like blog, user.id, etc. It's going to be a lot of typing though. So one thing we could also do to make this a little cleaner is to utilize an alias for all of our tables. So here, for example, we could just say B for blog user. We could say C for comment and P for post. And if we want to use these, now we could just specify B.id, C.id, P.id. And anywhere else that there's going to be similarities, user ID, for example, right? Both the comment and post table has user ID. So we want to specify both if we want both. So C.user ID, P.user ID. And I don't know if anything else is shared, so let's try that. Now, if I do run this, it's going to complain again because now that I've created an alias for all of these tables, I have to be consistent with how I reference these tables. So everywhere I have these on clauses, I can't use the original reference anymore. I need to use the alias. So let's go ahead, simplify that. Everything is now going to be utilizing an alias. This icon is here, P on, okay. So ID, P.user ID equals B.user ID. Okay, text, right? Posts and comments both have text. So C.text and P.text. Okay. Oh, right. I didn't want P.text. That was the whole thing we're trying to avoid. So let's get rid of P.text. And now we have a clean table where we can have it persist. So we don't have to like, I don't know, copy our results anywhere else or something like that. Okay. I just realized there was something that I wanted to also go through that I think I skipped over. So let's back up a bit. And this is in regards to running some of these commands, right? So I showed you earlier that we don't have to run this init.sql command because it's already been run inside of the Docker file at the entry point. Now, if we exit out of this, and let's say if we want to run another script, we have a few here. We have, let's take a look at script.c. Okay, so this script.sql is a selection. If we wanted to run this, we could use our docker exec command. But instead of just ending with the exec for the pSQL command, we want to add on to it. So right now we're passing in the host, the port, the user, the password, and the database name. I'm sorry, we're not using password. And from here, we can also use something like the -f command to pass in a file, right? So if we were to try to do that with our, what was it called again? Script.sql, it will not run. And that's because even though that file and directory, or that file is in this directory, we're passing this command into our container, right? And this file doesn't exist in the container. So we have to copy the file into the container first. And there's actually another way to do this so that we don't have to copy the file. So let's do CP. Actually, we want to do a Docker CP because we want to copy it into the Docker container, and it's just script.sql. And we want to specify a location for it. So inside of our database, which is just pg_db, let's put it in, I don't know, a temp directory. So script.sql. Okay, it's been successfully copied. Now we are able to run this command. Oh, if we specify the directory correctly. Okay, so we put in temp folder. We made sure to specify that we're calling it from within that temp folder, and it ran a command. Now, what if I don't want to copy a file over because let's say my use case is just immediate, right? Or I don't know, ephemeral. I'm not creating any code that I want to run consistently. I just want to look at a few things, and I want to be able to do this without typing these commands out over and over inside of PSQL, right? So that's where I can make something like this very simple temp.sql, and it's already got some stuff in it. But let's start with that right there. This is essentially the same code we had just run inside of the terminal. Now it's a little cleaner, right? It's, again, SQL doesn't care about white spaces. So we could have new lines in between all of these different clauses, which makes it a little more reader friendly. And it will run the exact same way as it would inside of the PSQL terminal. So if I don't want to copy this over into my Docker container, instead of running this -f option, I could use a Linux redirect. So redirect is this little caret. It's basically saying, hey, I want to throw the contents of this script into my container where I'm calling this command. So now if I run enter, ooh, the input device is not a TTY. I think I might be missing something. So PGDB. Okay, so I have to, instead of this -it, I need a -I, and I don't exactly remember interactive. So when we use the -it, I generally say interactive terminal because that's how I remember it. We don't need to allocate a pseudo TTY. We just need this interaction in order to run the script. So again, if I wanted to run a script without passing it into a container, I could just use this redirect instead of the -f, which specifies the file name that I want to use. And I could use -i interactive to do that. Okay, so now we're able to see that same command that we ran before. So a few commands actually. I had that uncommented. And as you can see here, actually, we are able to just comment in and comment out code as we need them, right? So that's one of the cool things about just being able to run something from a script. I could grab this same query, I could uncomment it, I can just rerun my command, and boom, we get the answer that we want. So by all means, you could also just copy a file into the container and continue running it that way. But if you were to update that file, you would have to recopy it over and over into the container. Or maybe have a different terminal and use Vim in that terminal to update the file. More than one way to skin a cat, but this is probably the fastest right now. That's, I think, about it. Today's README didn't really have a lot to go over. We talk about creating the schema, how to implement that SQL, and oh, yeah, there's some queries that we could talk through a little more, right? Because we really just ran these queries from a script. So if we wanted the name of a user with the most posts, we want to grab from the blog user table. We want to use count because we just want to count instead of the actual row data. And we're also looking for posts. So we want to join that with the post table. We specify where we want to match. And then we group by the username and we order by account in descending order. And that's going to give us that result that we saw earlier. And if we run this, where we're looking for the top 3 comments with the most comments, this is a little trickier. So let's break this down. Here, it's pretty straightforward. We're still selecting account, and we are, I guess, to avoid confusion, specifying an alias for this c1.id. So this is a comment ID specifically from comment table C1. We're referencing the exact same table, so we have to use an alias. Otherwise, there's going to be confusion, not just for us, but for the interpreter as well. It's going to throw errors. It's not going to know which table we're referring to, right? Because they're both named comment. So we use an alias, C1 for our first search, and we join it for another search through that same table using C2. And we can set inequality for the ID in our first search to the parent comment ID in that second search, because we're looking for the child of a comment, right? And that child of a comment, it has a column called parent comment ID that will point to its parent's ID, right? So we could set equality this way. And once we do that, we can group by the IDs in the first search, and then we organize in a descending fashion. So let's take a look at what that looks like. Right. And we get a count in descending order of comments associated with a comment ID. So another way to think about this, well, not really another way to think about it. Before we even attempt that, let's just talk about this, a few more aspects of these columns. This count is a count that is run on that second table. And this comment ID is from the first table, right? And we could use that equality for the comment ID in the first table, our first run through, with the parent comment ID value in that second table. And I don't even know if that's helping. This is very circular, but let's take a look at the comment table again. Oh, right. I'm outside of my terminal, so this isn't going to work, but I could just copy paste this in here. And let's do a limit for 1. Whoop. Select all from comment. And right, we see inside of here that every comment has a parent comment ID. Let's actually expand this to 10. And so if it's a comment to a comment, it's going to have a parent comment ID. Otherwise, we know that its parent is a post. And knowing these things allows us to write wonky scripts like this following beast of a script here. And right, this is this is just to show as an example, but there's some interesting stuff happening here. And maybe what we really just want to look at, instead of like trying to break this down line by line, is the interesting things happening with these parentheses, right? What these parentheses represent is a subquery. So we're creating a subquery that we're going to call, and then we're using those results in another query. And the results from that is what we join with our blog user table. Right. So go ahead and start on the challenge today. Go through the README if you haven't yet, and maybe take some time to chew on this query. And if anybody is feeling confident, we can see if anyone can talk us through this step by step, line by line later on during stand down. Okay. How's everyone doing? Are we all good?
I will need some help after this.
Sure. Do we need any more demos on anything? Do we want to go through like a challenge from yesterday or anything like that?
I'm at a place right now where we went through so much so fast. I won't know if I even understood you till I try to do it.
Oh.
So I don't know what to ask right now. I've got to try and see if I understood what you said or not by trying it.
Okay. Okay. All right. If yeah. Should I go through the lesson like just briefly? Again, like just kind of like at a high level recapping what's happening. Will that be a little helpful?
By the lesson, do you mean the README? Is that what you mean by the lesson?
Yeah, today's README.
I'm not even sure.
Okay. Well, let's see. Let's just go through one more run of this. So schema design, consider that its own topic. It's maybe something that you'll pick up just by going through on your own and playing around with the quick database diagrammer. It seems like folks have a pretty good grasp on relationships, on primary keys, on foreign keys. A lot of the syntax for the SQL code itself, again, you'll get familiar with over time. And if you're still having trouble with like some of these commands, these cross-environment commands, like being able to run a SQL file on your local machine inside of a container that's running a PostgreSQL environment, I could definitely see where that can get tricky. So, yeah.
And you did it fast, but it looks like if I want to do a new query, I have to reload it, right? You did it like without even thinking, but
Oh, yeah.
Right? You reloaded it, made a change, reloaded it. You just did all that.
Yeah, sorry if I clear my screen way too much. It's just habit, but yes.
Okay.
So let's actually yeah, let's talk about that one more time. So we have the command where first, Docker exec by itself allows us to run a command, right? And in this case, we're saying we want an interactive session, and it's going to utilize TTY, which I can't really explain right now, but it's what allows for the terminal session itself, right? We specify the container we want to run, and then the command that we're passing in. Like this is all a single command. Just like you would run on your local machine if you wanted to connect into a SQL terminal on your local machine. You just run post PSQL, and then you're passing in these necessary arguments. So host, port number, username, and the database name, which is blog. Now, this allows us to go inside of our Postgres terminal inside of our container.
And you said we have to get rid of the T and just do the -I, or was it the other way around?
Well, the T is for the terminal, right? So if you want to just run a file using that redirect, we don't activate a terminal to do that. We just have that command run. So we still need the I because it needs to be an interactive execution, right? And instead of a -F, which is an option that points to the file inside of the container, we're using this Linux symbol for redirecting. And that basically says, I want to use the contents of this file for this command. Redirect is, I don't know, I don't remember how much Linux you all went through, but like basic commands like echo will say something, right? Like echo, I don't know, hello world. That just prints hello world. It's like console.log inside of JavaScript. It's like print inside of Python. Now I could use my redirect to store this output into a file, hello.txt. And now if I look inside of my environment, I've created a file called hello.txt. If I look at that file, it contains the output of this command. So that's what redirect is. It's a pretty cool little Linux command. There's maybe some like advanced functionality to it, right? Like if we were to run this command again, it's going to overwrite the contents of that file. So what we could do instead is use the redirect 2 times to add to that file as opposed to overwriting it.
And the first time you use the redirect, if the file already exists, it just puts it inside there. If it doesn't exist, it's like touch, it creates it.
Well, when you say the first time I use the redirect, are you talking about like this example right now?
Anytime, if I'm going to use the redirect, if the file is already there, I just use redirect file name. If the file isn't there, I do redirect file name and it creates it for me.
Exactly, yes. But if you do it and the file already exists, it's going to overwrite it.
Okay.
If you don't want to overwrite it, you could just use 2 symbols to represent adding to the file as opposed to overwriting. And I was able to have both print statements because of that. Now, redirect, I don't know if you can actually, I don't know of a way to read more about the symbol itself inside of your terminal, because again, we have man, which is short for manual, that we could run on any command just to remind us what it is, right? I don't know if we could do that for redirect. But we do see that there is some like really cool functionality where we could have it point in another direction, right? So this is essentially the same thing. We're like creating like a file in memory that we are then passing in to this PSQL command running inside of the Docker container.
I thought I followed what you were saying, but now I have a greater than sign and a less than sign, and I don't know which to use for what.
Sure. Yeah, in this case, it's just a less than sign. Just think of it as temp.sql pointing to this command, right? The contents of this file are going to be passed in, are going to be redirected into here, right?
Okay.
And
Yeah,
then,
the greater than and the two greater than, weren't those, when you did two, weren't those greater thans? Yeah, there you go.
so yeah, I'm taking the output of this command and I'm throwing it into hello.txt. Yeah, again, if look online for some documentation on redirect, it could maybe explain just like its nuances in a little more detail, but that's one way to just quickly run a file. Because otherwise, if you wanted to do it with the -f command, you would have to update the file inside of the container every time you want to update the code.
And if you don't want to do either one of those, you just have to type the whole thing out in your terminal, right? Select this from that. So that's what this is, to keep you from having to do that.
Exactly. Yeah, they're just two different ways of running SQL queries. We could either do it straight up from inside the terminal, or we could do it a little more programmatically through a script.
Okay. Thanks for taking time to explain that more. I appreciate it.
Sure. Yeah, sure.
There
Yeah,
was another one in the do you want to do breakout rooms, in case there's probably people that are already ready to just go do the assignment? Don't
yeah.
want to look at all my questions.
I know, and that's gonna be. I'll open up breakout rooms. You could take a break, and yeah, I'll be around to answer questions.